1809, Ernest Rutherford changed the Thomson-Plum pudding model of atom that was composed by electrons and protons uniformly mixed throughout the atom. He was supported by Ernst Jünger and Ernst Marsend and to do an experiment proposing another model of atom. He discovered the central charge region, later named the nucleus, formed by protons with positive charge and neutrons with a neutral charge. He suggested that a large amount of atom charge is concentrated into it, so it has a very high electric field. Outside of that, he proposed that the atom was mostly empty space and surrounded by electrons that have a negative charge and they exist orbits or shells. The universe is made up of matter, in the form of particles and waves, in the form of electromagnetic radiation. They are form of energy. Every wave is thought as packet of energy. Each packet is referred to as a photon. The formula is E equal h per f, and h is the Planck constant that is equal to 6.63 for 10 times minus 34, and also is equal to h for c over lambda, that is the wavelength of radiation.
Returning to the periods, they are divided in quarks and leptons. All matter in the universe has their own opposite. For example, we can summarize it in a table. All matter and antimatter can divide it in two different groups, hadrons and leptons. Hadrons is influenced by strong force and will interact via the strong force. Leptons won't interact via the strong force. The hadrons is always divided in two different groups, baryons that will eventually decay into a proton. Meson won't ever decay into a proton. Baryons can be proton and neutron, and the structure of the quark are 3 quark or 3 antiquark. All quark have plus 1/3 baryon number. Meson can be divided in pion and kaon. Their structure is quark and antiquark. All quark have minus 1/3 baryon number. Lepton can be electrons, neutrino. They work in pair, mu neutrino and antineutrino. The particle and waves can change with other particles or waves. This change can be due to an interaction or by decay. Interaction can be divided in annihilation and part production. In an annihilation, a particle and its antiparticle collide and destroy each other to produce two identical photons of gamma radiation. Example, electron and positron. But the mass minus energy plus kinetic energy before the colliding must be equal to the photon energy after the colliding. In the peak production, a photon can spontaneously decay into any number of particles and corresponding particles. Photons equals particle plus antiparticles. In the universe, there are 4 different types of forces: strong force, electromagnetic force, weak force, and gravitation force. The Feynman diagram is a diagram that can describe the interaction between particles. We have a lot of examples about it: beta minus decay, beta plus decay, electron collision, electron capture, and particle repulsion.